In this video, I want to introduce the idea of implicit differentiation, and we can think of this as an application of the chain rule. This is kind of an interesting application, and in this video I'm going to introduce the idea. In the next video, next several videos, we'll see how it's actually used. So to begin with, let's recall what the chain rule says. The chain rule is a shortcut rule that allows you to take the derivative of a composition of functions. So if we have g of x inside f of x, so it's kind of like, in the drawings that I drew looked like this. It's like our outside function is f of x, and inside f we have g of x. And so to take the derivative of the composition, I take the derivative of the outside function, evaluate it at the inside function, and then I multiply that by the derivative of the inside function. Okay, and we get this. So the way that I would use it here is we have our outside function is the square root of x, so I could write that as a power, like this to the half power, and it looks like inside of that I have x squared plus 1. So this square root of x, or x to the half power, is like the outside function, the f of x. Inside that is x squared plus 1. That's like our g of x. So I take the derivative of the outside function, bring the 1/2 down, subtract 1, evaluate it at the inside function, and then multiply it by the derivative of the inside function. So the way I take this derivative then is I take the derivative of the outside function, 1/2, and then I'd evaluate it at the inside function, x squared plus 1, and then I'd have to the negative 1/2. So the derivative of the outside function is bringing the 1/2 down, subtracting 1 to get negative 1/2, evaluate it at the inside function, but then I have to multiply by the derivative of the inside function. So the derivative of x squared plus 1 is just 2x. And so then I would get this, and then you could rewrite that as something like maybe 2. Well, the 2's would cancel out here, so I would just have like x on top, and on bottom would be like the square root of x squared plus 1. So you could simplify it like that. Okay, so that would just bring that to the bottom. But that's the chain rule. Okay, so what the idea of implicit differentiation is when you have expressions that involve an x and a y, and you want to take a derivative of that expression with respect to x. Okay, and so you can think of y here as being a composition of the square root function. So let me show you what I mean. So we got like the square root function would be like this, and to the 1/2 power, and then inside of there we have y. But what I'm going to do is I'm going to assume that y is going to be some function of x. That's the implicit. So implicitly it's some function of x, even if it's a constant function, right? In which case the derivative would be 0, but y is like some function of x, right? Y of x is inside the half power. So y of x is an inside function, the square root is the outside function. So, and this y is a function of x, okay? So notice that y prime of x, we could rewrite that as dy dx. So I use dy dx. I can think of that as dy dx. So the derivative of just y is dy dx. Oops, sorry. The derivative of y is just dy dx. So I'm not going to write it like this and use this sort of notation. I'm going to use this kind of notation. Okay, so to take this derivative, I'm going to run out of room here, so I'm going to write it down here. I'm going to take the derivative of each piece. I'm going to split the derivative up over the sum, and taking the derivative, and maybe I'll write that out. dx of x squared plus d dx of, and I'm going to write this as y to the 1/2, right? Like that. So I'm taking the derivative of each piece. So the derivative of this with respect to x is just 2x. Okay? But the derivative of this, I'm going to use the chain rule. I'm going to take the derivative of the outside function, so this would be plus. Derivative of the outside function would be 1/2, evaluated at the inside function, which is y of x, so which I'm just going to call y. This would be negative 1/2. And then, but then I have to multiply that by the derivative of the inside function. And the derivative of y with respect to x is dy dx. So the derivative of this thing with respect to x is all of this. And then you have this expression here of the derivative of y with respect to x. And so you're really using the chain rule here. You have the square root on the outside. You have y on the inside, and y is some function of x implicitly. We don't know what that function is, but I can take the derivative of the outside function, evaluated at the inside function, which is y, times the derivative of the inside function, which is dy dx. So it would look like that. Okay? So let's try some more examples here, just to get the hang of this. And then in the videos after this, you're going to see why we do all of this. Okay? So this one, I have an outside function, right? Which is the square root function. So I'm going to take the derivative of that, evaluated at the inside function. So it'd look like that. And then I need to take the derivative of the inside function. So the derivative of the inside function, this would just be 2x. But then this one, again, I have to think of the outside function as being, I think of the outside function as being like 3 times something. And then I have y on the inside. So 3 times something, the derivative, if it was 3x, it would just be 3. I'm sorry, this is like or you can think of this as a constant multiple of y. This is kind of confusing. So I could think of that as a constant multiple. And so the derivative of y with respect to x is just dy dx. So 3 dy dx. That's maybe a little more clear. Okay? And so this is what this would be. So the derivative of the outside function evaluated at the inside function times the derivative of the inside function with respect to x. And here y is implicitly as an implicit function of x. Okay, so let's try this one. So this one can be thought of as a product of two functions, 3x and then y being an implicit function of x. So using the product rule, I'll take the derivative of 3x times y, and so that would just be 3y. And then I add 3x times the derivative of y, and derivative of y is just dy dx. Okay, so it would look like that. So I'm using the product rule with y as an implicit function of x. Okay? So now here we don't even have an x, but we are going to consider y as an implicit function of x, and I'm going to take the derivative with respect to x. So I'm going to use a product rule, but both of these I got to think of as a chain rule. Okay, so let me just do the product rule first. The product rule would be d dx of y squared times sine of y plus y squared times d dx, the sine of y. So this would be the product rule, the derivative of the first function times the second function, the first function times the derivative of the second function. And now I'm going to treat these like this being y, like you have something squared and I'm putting y inside. So this would be 2y times dy dx. So this would be 2y times dy dx. And then times the sine of x. And then this would be plus, and then this would be y squared times, this would be the derivative of sine of x. So this is like the sine with y inside. So this would be cosine of y, and then times the derivative of y with respect to x, dy dx. So I would get all of this, okay? So this is the idea. I know it's a little strange, but in the next video, it'll become clear why we do this and how it could be useful. The next couple videos. So we'll move on.